Hi there! In the previous lessons, we talked about variables and basic arithmetic operations in Java. In this video, we will learn about relational and logical operators in Java. These operators are fundamental tools for making decisions in your programs. There are several relational operators we can use to compare values, and there are logical operators to combine multiple conditions together. Don't worry if this sounds complicated. We'll go through each operator step by step with clear examples. In today's lesson, we have two key objectives to accomplish together. First, we'll explore relational operators, where you'll learn how to compare values using less than, greater than, equals, and not equals. Second, we'll master logical operators, including and, or, and not, which let you combine multiple conditions to create sophisticated program logic. Let's start by building a solid foundation and understanding what relational operators actually are and why they're so important in Java programming. Relational operators are the comparison tools we use in Java to evaluate relationships between values. They allow us to ask questions like, is this value greater than that value? Or, are these two values equal? And they always return a Boolean result, either true or false. Think of them as the decision-making foundation of your programs. These operators are everywhere in professional Java programming. You'll use them in if statements to control program flow, in loops to determine when to continue or stop, and in any situation where your program needs to make a choice based on comparing values. Mastering these operators isn't just about writing comparison code. It's about understanding how programs make intelligent decisions. Now that we understand what these operators are and why they matter, let's see them in action and discover how each one behaves with real numbers. All right, I've got our starter code here. In the exercise project, I've created a class called Relational Operators Example with the main method already set up. If you're ready, let's move on and make some examples using relational operators. First, we need to create some variables to work with. I'm typing integer a equals 5. This gives us our first comparison value. Then, integer b equals 10. And lastly, integer c equals 15. So now we have three integer variables with the values 5, 10, and 15 that we can use for our comparisons. Now let's see how the less than operator works. I'm using the println method to display the result. I type a less than b, and then I put the comparison a less than b inside parentheses. This will check whether 5 is less than 10. Next, let's add the greater than operator. I'm typing b greater than c, and then the comparison b greater than c in parentheses. This checks whether 10 is greater than 15. Now let's look at the equality operator. Note that in Java, we use two equal signs to check if values are equal, not just one. This is important to remember. One equal sign is for assignment, but two equal signs is for comparison. I'm typing a equals c, and then the comparison a equals c in parentheses. This checks whether 5 equals 15. And finally, let's see the not equals operator. We use the exclamation mark followed by an equal sign. I'm typing a not equals c, and then the comparison a exclamation mark equals c in parentheses. This checks whether 5 is not equal to 15. Now let's run the complete program and see all our comparisons in action. Perfect! As you can see on the console, we get a less than b, true, because 5 is indeed less than 10. Then b greater than c, false, because 10 is not greater than 15. Next, a equals c, false, because 5 does not equal 15. And finally, a not equals c, true, because 5 and 15 are different values. Each comparison behaves exactly as we would expect based on the mathematical relationships between our values. Now that we've mastered relational operators and understand how to compare individual values, there's something crucial we need to understand, and that's logical operators. These operators allow us to combine multiple Boolean conditions together, which is essential for creating sophisticated program logic. Let me show you exactly how they work. Logical operators are special tools that work with Boolean values, which means true and false. They let us combine simple comparisons into more complex decision-making logic. There are three primary logical operators in Java. The AND operator requires both conditions to be true. The OR operator needs at least one condition to be true. And the NOT operator flips any Boolean value to its opposite. You'll encounter these operators constantly in real-world programming. They're essential for checking multiple conditions in if statements, validating user input where several criteria must be met, and creating complex business rules that depend on combinations of factors. Understanding logical operators transforms your ability to write intelligent, decision-making code. Now that we understand what logical operators are and why they're powerful, let's see them in action with concrete examples. Let me create a new class called Logical Operators Example. I've got our starter code here with an empty main method. This time, we will use Boolean variables to demonstrate logical operators. First, we need to create some Boolean variables that represent different conditions. I'm typing Boolean condition 1 equals true. Then, Boolean condition 2 equals false. And lastly, Boolean condition 3 equals true. These variables will help us understand how logical operators combine conditions in different ways. Now, let's explore the AND operator, which is one of the most important logical operators you'll use. The AND operator is written as two ampersands. The key thing about AND is that it only returns true when both conditions are true. If either one is false, the whole result is false. I'm typing condition 1 and condition 2, and then in parentheses, I put condition 1 ampersand ampersand condition 2. This will check if both condition 1 and condition 2 are true. Now let's see a case where AND returns true. I'm typing condition 1 and condition 3 and the comparison in parentheses. This checks if both condition 1 and condition 3 are true. Next, let's explore the OR operator, which works quite differently from AND. The OR operator is written as two vertical bars. The key thing about OR is that it returns true if at least one condition is true. It only returns false when both conditions are false. I'm typing condition 1 or condition 2, and then, in parentheses, condition 1, vertical bar, condition 2. This checks if at least one of these conditions is true. Now, here's something more complex. Let's combine the OR operator with the NOT operator. The NOT operator is the exclamation mark, and it flips a Boolean value to its opposite. I'm typing condition 2, vertical bar, exclamation mark, condition 3 in parentheses. Let me explain what happens here. First, NOT condition 3 takes true and flips it to false. Then we have condition 2, which is false, or false. Since both are false, the result should be false. The NOT operator is very useful when we want to reverse a Boolean value. Let me show you two simple examples to make this crystal clear. I'm typing NOT condition 1 with the comparison in parentheses. This will flip condition 1 from true to false. And finally, I'm typing NOT condition 2 with the comparison. This will flip condition 2 from false to true. Now, let's run the complete program and see all the logical operations together. Perfect! As you can see on the console, we have all the results displayed. We see condition 1 and condition 2 false, because even though condition 1 is true, condition 2 is false, so the AND operator returns false. Then condition 1 and condition 3 true, because both conditions are true. Next, condition 1 or condition 2 true, because condition 1 is true even though condition 2 is false. Then condition 2 or not condition 3 false, because after the not operation, both sides ended up being false. We also see not condition 1 false, because condition 1 was true and got flipped to false. And finally, not condition 2 true, because condition 2 was false and got flipped to true. These results show exactly how logical operators work to combine Boolean conditions in different ways. The AND operator needs both conditions to be true. The OR operator needs at least one condition to be true. And the NOT operator flips any Boolean value to its opposite. Congratulations! You've now mastered both relational and logical operators in Java. Let's quickly recap what we've learned today. We started with relational operators, which are the comparison tools that let us evaluate relationships between values. We explored less than, greater than, equals, and not equals. These operators always return Boolean results, either true or false, and they form the foundation of decision-making in your programs. Then we mastered logical operators, which enable us to combine multiple Boolean conditions together. The AND operator requires both conditions to be true for the result to be true. The OR operator requires at least one condition to be true. And the NOT operator inverts any Boolean value to its opposite. In our next lesson, we'll build on these foundations to explore conditional statements, where you'll see these operators come to life in controlling how your program responds to different situations. Keep practicing with different values and combinations, because the more you work with these concepts, the more natural they'll become. Great job finishing this lesson. You've tackled fundamental concepts that you'll use in every program you write. Go ahead and take a well-deserved break, and I'll see you in the next lesson where we'll continue building on these fundamentals. Thanks for watching.